So we know the graph of sine. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. 3 pi over 2 is at -1. And 2 pi is back to 0. So sine looks like this. Okay, if I want to draw the derivative of this, anywhere it has a horizontal tangent line, we know the derivative would be 0. So where would this have a horizontal tangent line? Pi over 2 and the 3 pi over 2. So it's 0 twice. The function is increasing here, which means the derivative is positive. Function is decreasing, yes.
The derivative of sine is cosine.
How did you know?
I can just tell.
You could tell already.
Yeah.
The function is decreasing here, so the derivative is negative, and then increasing again, so positive. So Danny is correct. The derivative of sine is cosine. All right. So we could also prove that using the definition of derivative. So I'm going to show you both ways. We looked at the graph. We're pretty sure that's right. Danny tells us it is, so we believe him. But if we wanted to work it out, we would do the limit as h approaches 0, back to that definition. F of x plus h, so sine of x plus h, minus f of x, so sine of x, all over h. Yesterday I wrote down 2 trig formulas that I told you we would be using in this section, and one of them was the sine of x plus h formula, wasn't it? So tell me that formula. Flip back in your notes where you wrote it down. I still have this minus sine x plus u. Okay. So you'll notice these terms have something in common. What do both of those have in them? Sine x. So I'm going to put those together, and then I'll leave the other one out. So I could think of it as this. Oops. Oh, I tossed my turn, didn't I? Plus that other fraction. You can put each one over the denominator. So I'm just breaking apart my fraction. Now we know with limits, if you have 2 things added together, you do the limit of each one. I'm going to go ahead and factor out my sine x on this one. If I pull that out, that leaves me with cosine h minus 1 over h plus this limit. I'm going to pull out my cosine x here. I'll show you why in just a second. We're trying to get to the point where we can plug in a 0 for h. If you look back, the last box we had yesterday, what is the limit as h approaches 0 of cosine h minus 1 over h? 0. So this is just sine x times 0. Over here, cosine x, that doesn't have an h in it, so it just gets treated like a constant. What's the limit as h approaches 0 of sine h over h? Look back at the first box we had yesterday. 1. And lo and behold, we get cosine x. So this actually can be proven using the definition of derivative. So from this point forward, you have to know the derivative of sine is cosine. so let's do an example using. If I want to find the derivative of x squared sine x. Notice I have two x's in this. Is there any way I can actually work it out and get it to just one x? No. So how would I have to do this? What rule am I going to have to use? Product rule. We have things being multiplied, so we're going to do the product rule. So product rule says the derivative of the first. So my two things are my x squared and my sine x. So the derivative of the first would be 2x times the second plus the first times the derivative of the second. And the derivative of sine x is cosine x. So we just get 2x sine x plus x squared cosine x. So now we need the derivative of cosine. We're working towards all 6 trig functions. We probably won't do all 6 of them today. We'll do a few. I'm going to prove cosine for you. I'm not going to prove all of them as we go along, but I'll prove the first few anyway. I'll just kind of show you why. If I wanted to do this one, we could do the definition of a derivative. So the limit as h approaches 0. F of x plus h, so it would be the cosine of x plus h, minus f of x, so that's cosine x, all over h. I failed to, if you want to add to those formulas from yesterday, I should have written down this one. The cosine of x plus h is cosine x cosine h minus sine x sine h. So, now I can use that formula right here. So we go to cosine x, cosine h, minus sine x, sine h. We still have the minus cosine x on the end. So we're going to do something pretty similar to what we did on the last one. If you look, both of these terms have a cosine x in them. So I'm going to rewrite my problem, pulling apart this fraction, and putting those together so we can treat this as cosine x, cosine h, minus cosine x over my h, minus the sine x, sine h over h. So just reordering my terms, pulling apart my fraction. And so then, on the first one, we could pull out a cosine. Take out the cosine x, you're left with cosine h minus 1 over h, minus, if we do the limit of the second one, if you separate that, the sine x, you have sine h over h. Okay, so cosine x, it doesn't have an h in it, so it stays the same. What is the limit as h approaches 0? Cosine h minus 1 over h. Minus sine x, it doesn't have an h, so it stays the same. Limit as h approaches 0, sine h over h. And we get negative sine x. So the derivative of sine is cosine. The derivative of cosine is negative sine. So that is the next thing. This section does have several things we just have to memorize. So you might have to make yourself a few flashcards or something if you're struggling with that. I'm also going to go ahead and give you the derivative of tangent. I'm going to prove that for you. We could find this. Basically, we did the others using the definition. Now we could prove all the remaining ones using quotient rule. We know that tangent is sine x over cosine x. So if you want the derivative, quotient rule is low, so the bottom. D high, what's the derivative of sine? Cosine. Minus high. D low, what's the derivative of cosine? Over low squared. So cosine times cosine is cosine squared, minus sine times negative sine, that would become a positive sine squared over cosine squared. What's cosine squared plus sine squared? And 1 over cosine is secant. Since it's squared, it is secant squared. So the next thing, if you know the derivatives of sine and cosine, even if you forgot the other 4, you could work all of them out doing quotient rule. And it's not the fastest thing, but it doesn't take too terribly long. Hopefully, by the time we get done with this, we're going to do a lot of practice. We should get to the point where we just know them. But worst case scenario, you could work that out again, doing quotient rule. Alright, let's do a few derivatives. Those are probably the only 3 trig functions I'm going to give you today. We'll do the other 3 for tomorrow. So we're just going to do a few more practice ones and then maybe give you guys some homework time at the end today. So if I want to find this derivative, what would we have to do? Quotient rule. Because I have an x on the top and an x on the bottom, there's no way to simplify that into a single x, so we have to do quotient rule. So that is low. So the bottom, 1 minus sine x. D high, what's the derivative of cosine? Minus high, so cosine x. D low, what is the derivative of 1 minus sine x? So the derivative of 1 is 0, minus, what's the derivative of sine? Cosine. So we get a negative cosine x because of that minus sign. Is everybody with me right there? Over low, so that's the 1 minus sine x squared. So if we start simplifying, if I distribute, 1 times negative sine x is negative sine x. Negative sine x times negative sine x is positive sine squared x. Minus cosine times negative cosine, so that makes plus cosine squared x. You notice anything we can simplify here? We could FOIL out the bottom. I don't really want to. Sine squared plus cosine squared. That is 1. So then if I put that in front, I have 1 minus sine x over 1 minus sine x squared. So we could cancel a 1 minus sine, couldn't we? Cancel 1 on top and 1 on the bottom. That leaves us with 1 over 1 minus sine x. This sine squared plus cosine squared comes up a lot in our derivatives, and I do expect you to know and recognize that that is 1 and change it to simplify here. Questions on that? Okay. So we have a cosine to the third. We know how to do the derivative of like an x to the third, but if it's anything else to the third power, we don't know how. So if it were like x plus 1, we would have multiplied it out 3 times. So what I'm going to do is write this as cosine t times cosine t times cosine t. Okay. That third power just means we have 3 of them. All right. So if I start doing the derivative here, the x prime or the dx dt, we can do the product rule, but we're going to have to do it with 3 terms, which is a little bit different than what we've done before, but we can. So the idea is with product rule, you do 1 derivative at a time and everything else stays the same. So start with the first one. What is the derivative of cosine? So that becomes a negative sign, and the other 2 stay the same. Plus. Now we're going to do the second one. So the first one stays the same. The derivative of the middle one is negative sign. And the last one stays the same. Plus. Now the first 2 remain the same. The derivative of the last one is negative sign. So, if I simplify this, negative sine times cosine is negative sine t cosine squared t. Cosine times cosine is also negative sine t cosine squared t. And the last term, cosine times negative sine is also negative sine t cosine squared t. These are all like terms, so you add their coefficients, so we get negative 3 sine t cosine squared t. I'm going to throw in a couple examples not on this handout. We might just add them on the back or on a piece of notebook paper or something. I think there might be room on the last page. want you guys to try these. So the first, you would have to rewrite the cube root as x to the 1/3. And then what we have is a product. We have an x times a tangent of x. So we have to do the product rule. So product rule says derivative of the first, so that would be 1/3 x to the -2/3 times the second plus the first times the derivative of the second. Derivative of tangent is, and that's really all you can do here. You could drop out these parentheses if you wanted. But that's about it. Typically with these trig functions, your derivatives are probably going to get uglier with each step. It's not like a polynomial where it gets nicer as you go along. Okay, B. F of x. So this tells me that x is my variable. So any other letter represents a constant. So C here is just a constant. Okay, when you do the derivative of that, it's just going to be C times, what is the derivative of sine? Cosine. Minus. Now, let's talk about this. Here we have a product. You notice I put a bracket after this negative. One common mistake on the quiz was not distributing your negatives all the way through, so I'm trying to make it very clear when we need to do that. We have to subtract off this entire derivative. So I'm going to do the product rule to get that derivative. So derivative of the first is 6x times the second plus the first, 3x squared, times the derivative of the second. Derivative of tangent is secant squared x. So we get C cosine x minus 6x tangent x minus 3x squared secant squared x. And that's our final answer. It's just like, you know, when you do the derivative of the 3x, the 3 was just constant and we just trailed it along. So same idea. Okay, on C, what are we going to have to do here? Quotient. So, low D high. How are you going to do the derivative of the top of this?
Would it be 1 times the negative sign?
We're going to have to do the product rule because there's two x's multiplied together. So we're doing the product rule inside the quotient rule this time. So, look, D high, derivative of the top, since there's two x's multiplied, we're doing the product rule. So the derivative of the first times the second plus the first times the derivative of the second. Derivative of cosine is? Okay. Now we're back to our quotient rules. So we have low d high minus high d low. What's the derivative of the bottom? 3 over low squared. All right. If I simplify this, I have cosine x minus x sine x. Can I cancel a 2 plus 3x? Why? There's another term over here and it's not in there. So instead, we're going to have to FOIL this mess out. So, we get 2 cosine x minus 2x sine x plus 3x cosine x minus 3x squared sine x Anything simplified? Drop out that. So our final answer, 2 cosine x minus 2x sine x minus 3x squared sine x over the denominator. Okay. I think this is a good place to stop for today. We're going to try to take small pieces. We can see our derivatives are rapidly getting uglier. This is where neatness is really important, because if you can't read your terms, you are not going to be able to see which things cancel out and which ones don't. Okay, so make sure you are keeping your work neat. The homework, I think I'm going to slightly change I've listed out a few problems here, but instead of problem 12, I want you to do problem 9. Okay, so it's 1, 2, 7, 9, 10, 13. That's what I would like you to do for tomorrow.